So let's start with the first one. This one is kind of tricky, and I'll just briefly explain to you how this first one would work. You see, whenever you have a redox reaction, it's two reactions. So let me just explain a bit of a background of how this question would work. You have a reduction reaction, like I'll do an actual reaction. Let's say I have Fe3 plus 1 electron in equilibrium with Fe2 plus, and the potential is its E naught is 0.77 volts. And the other one is copper 2 plus 2 electrons in equilibrium with copper, and the potential E naught given is 0.34 volts. Now we know that one of them is the higher potential, the other one is the lower potential. It loses electrons, higher potential, it gains electrons. So this is what's happening, and you balance the number of electrons that are gained and lost. You multiply the first equation by 2 so that the number of electrons gained and lost are equal. And you add up the reactants and you add up the products. That is how you do it. So I'm just building up, I'm just trying to explain what this question would be asking for. So if I write this reaction, it's basically two reactions. The first one is in the forward direction. So let me quickly write that 2Fe3 plus 2 electrons, and it's forming 2Fe2 plus. That's my reduction. So this one is my reduction equation, this one. And this one is in the backward direction. That's my oxidation equation. So that's going in the backward direction. It's copper, and it's losing 2 electrons to produce copper 2 plus 2 electrons. And this over here is my oxidation equation. Now this is something that's fairly obvious. And if I add up the two reactants, that's my overall reaction, which is I sum up my reactants, which is 2Fe3 plus and copper, and I sum up my products, which is 2Fe2 plus and copper 2 plus. So everything is kind of straightforward. TK, this is something that we have been doing over and over again. One gains electrons, higher potential gains electrons, lower potential loses electrons. You sum up the reactants, which is copper and 2Fe3 plus, and you sum up the products, which are 2Fe2 plus and copper 2 plus. Now, this question is about this thing, that what if you know what the overall reaction is? Okay, so what if you know the overall reaction and you don't know any electrode reaction, you don't know what's happening, and one of the reactants over here, one of the equation is missing. So by looking at the two equations, can you figure out what this missing equation is? I mean, you know the final answer, you know the reduction equation, you know that. So, I mean, the reduction equation plus the oxidation equation, that is what gives you your overall reaction, which is over here. Let me just put this around it. So that kind of gives me the overall reaction. So how can I figure out what this missing reaction over here is? This is something I need to find out. So it's like a math equation. Okay, remember, you know one of the equation, one of the half reactions, the other one is not known, but you know the overall reaction. You know that this particular equation, which is Fe3 plus, adds up to some other equation, and then it results into this equation. So how do we figure that out? What you're simply going to do is, if you see copper 2 plus over here, then that means that kind of means that copper 2 plus must have been part of the reactants over here. That is why you're getting copper 2 plus in your final equation, because two equations got added, their products got added, and that's why you're getting copper 2 plus. Then you see copper over here on the left side. So that means there must have been copper in this equation over here. And then you see 2 electrons over here, and you don't see electrons in the final equation. That means there must have been minus 2 electrons over here, because this equation is going to be added to this equation, then you're going to get the final equation. So by looking at the final equation, I'm trying to figure out what this missing equation is. One of the reaction was given, the other was not given. And I'm trying to figure out what the missing reaction is. And I've been able to figure that out. So I'm just going to do this once more. Let's say, just once more. Let's say I have a reaction in which there's Na plus 1 or 3Na reacting with Al3 plus. And what is given is that Na gets oxidized, it forms Na plus 1, and aluminium gets reduced. So this is something that's given. That's my final overall reaction. That's my redox reaction. And I've been given that this reaction happens when you have two equations. One of them is a reduction equation, which is aluminium getting reduced and forming aluminium. So this equation is given. The oxidation equation is not given. So I want to figure out what the oxidation equation is. So this equation adds up with another equation to get this equation. So you'll just figure out that if you're getting 3Na over here, there must be 3Na in the oxidation equation on the left side as your reactant. You're getting 3Na plus 1 on this side, so there must be 3Na plus 1 on the other side. You have 3 electrons over here, but there are no electrons showing up over here. That means it's plus 3 electrons over here. There must be minus 3 electrons. So the reactants get added up, you get this. The products get added up, you get this. So that's how you're going to find the missing equation. Okay, so it's kind of like like doing everything in reverse. That the final answer is given, and you're trying to figure out what the missing equation is. Is this point clear? I mean, just this point. We'll move to the question now. Nadine, is this clear? Zuha, Maria, Ibrar? I don't know if you have.
Sir. Yes.
Achha, so now based on this, remember the question that we're going to try and attempt, that's slightly more tricky. So just remember, if they give you one of the equation, like one of the half reactions, and the other one is not known, and you know what the overall reaction is. So you're just going to do that if there's Al3 plus over here, there should be 3Na coming from this other equation. If there's aluminium coming from here, there must be 3Na plus 1 coming from this other equation. If there's 3 electrons and there's no 3 electrons in the final equation, there must be minus 3 electrons on this side. So I'm going to move to this question now. Now he's talking about a photosynthesis equation. So we're going to do everything in exactly the same way, what we just did. So he's given us the overall reaction. So let's write that reaction. It's 6 CO2 plus there is 6 H2O. And I've got my products, which are glucose, C6H12O6. And there is 6 oxygen gas molecules. So remember, this over here is my overall reaction. So this reaction was made up of 2 half reactions. And he's given one of the half equation, which is this is my oxidation equation, because electrons are being produced over here. So that means I've got my oxidation equation. I just want to figure out my reduction equation. So the oxidation equation is given. It's 2 water molecules. And those 2 water molecules are turning into what? O2 plus 4H plus 4 electrons. So that's one of the equation, one part of the equation. So I mean, that part is known. Now by looking at the equation, the first thing I'll figure out is, like, this equation needs to get added with this equation to give you this equation, right? I just go back to our working. Like, how did you make the overall equation? Like, the first thing was, like, when you make you balance the number of electrons gained and lost, right? You multiply one of the equation or the other equation by some number, so that the number of electrons gained and lost are equal. That is something that you do when you try to make this overall equation. Like over here, I mean, the actual equation was Na turning into Na+1 and losing 1 electron, but since it was gaining three electrons, then Na was multiplied by 3. So the equations need to be multiplied by certain numbers. So if you look over here, look at this equation. In my final equation, I'm getting 6 O2 molecules. So that kind of indicates that there should have been 6 over here, because I mean, my hunch is it should be 6 O2 over here, because how can this add up with something else to give you 6 O2? So there must be 6 O2s over here. So I'll multiply the first equation by 6. And if I do that, this becomes 12 H2Os. This becomes 6 O2. This becomes 4 into 6 is 24. And 4 into 6 would be 24 electrons. So I just wanted 6 O2s in my final equation, so I just multiplied this equation by 6. So what is my missing equation now? That's what we're going to focus on. So the missing equation, which is my reduction equation. So I'll just look at my reactants. Like I've got 12 water molecules over here. Something must get added to it to give you this. So what is that thing? I mean, there must be 6 CO2s getting added over here. So there must be 6 CO2s over here. So 12 water molecules plus 6 CO2s on the reactant side. But the problem is I'm getting only 6 H2Os. So there must be something. I mean, there should be minus 6 H2Os over here. Only then can my reactants add up to give me this. Like 12 water molecules minus the 6 water molecules over here, that gives me 6 H2Os, and 12 water molecules plus 6, that's where I get 6 CO2s. So is this part clear?
Yes, sir.
So then you've got the other side. So this is going to get added up with the products from the reduction equation to give you this, right? So one thing is there's no glucose over here, so there must be glucose over here, C6H12O6. H12O6, just a second. So C6H12O6. What else? There's 24 H+1 over here, but you don't get anything over here. So there must be minus 24 H+1. There's plus 24 electrons over here. In the final equation, the overall equation, there is nothing. So there must be minus 24 electrons as well. So will this get added up with this to give you this? Just have a quick check. 24 H+1 will get cancelled out. 24 electrons will get cancelled out. And you'll only have glucose plus 6 O2s coming from there. So I have finally this equation, which is kind of a weird looking equation at the moment. Why? Because in equations, you don't really have minus signs. So all equations are like math equations. Like there's plus 4 electrons on this side. If I take the 4 electrons on the other side, it's basically minus 4 electrons. So equations are like math equations. Like you can switch them around. So normally in chemistry equations, you don't have minus signs. So if I want to get rid of the minus signs, what I need to do is I need to rearrange this. Take minus 6 H2Os to the other side, it would become plus 6 H2Os. So it's 6 CO2s. I'm going to take the 24 H+1 and 24 electrons on the left side. So it's going to become plus 24 H+1 and plus 24 electrons. And on the product side, I'm going to have glucose, C6H12O6. And what else? I'm going to have 6 H2Os. Okay, so that's the reduction equation that was missing. I mean, the question had given us the overall reaction. The question had given us one of the equations, the oxidation equation, but the reduction equation was missing. And based on the idea that the oxidation equation plus the reduction equation makes the overall equation, so we were able to figure out what those missing things were. That this thing must add up to something to give you this, right? And this thing over here must add up to something to give you this. So we figured out what that something was. And then I rearranged, I got rid of the minus signs because in chemistry equations, you don't have minus signs. So you had to, just like a math equation, sort of rearrange things. And when you did that, you got this. So is this question clear, this one?
Yes, sir.
Okay, Zoha, is this clear? Nadine, Sam?
Yes, sir.
So just remember, okay, whenever you have, I mean, just for practice, we can do just a couple of random reactions. Just let me, like, I can pick any two equations, and I can quickly, just a second, where's that? This is, so what I can do is I can, let's pick these two. I mean, these two are right next to each other. So I'm going to do one way, then I'm going to do the same thing in reverse. So here are my equations. So I'm going to make the equation first. It's a pretty obvious reaction, like who gains electrons and who loses electrons. So just a second. So pretty obvious, higher potential gains electrons, lower potential loses electrons. The electrons need to be balanced. So there should be 6 Cr3 plus and 6 Cr2 plus and 6 electrons. So that needs to be multiplied by a certain number, and you make up the overall equation, which is going to be, you add up the reactants. In the first one, the reactant is 6 Cr2 plus, I think. Lower potential loses, higher potential gains. Over here, you've got Cr2 7. And it's 2 minus plus 14H plus 1. And the product in the first one, the product is 6 Cr3 plus. And in the second one, the product is 2 Cr3 plus. Plus 7 H2s. Now, 6 Cr3 plus 2 Cr3 plus can be written as 8 Cr3 plus over here. So what I have is 8 Cr3 plus, and I can try and move this over here. So this is my overall equation. And so I'm going to apply the same thing. So let's say I'm given one of the reactions. Like I'm given the reaction, the first one, and not even a complete reaction. I'm just told that it's Cr2 plus, and it's losing electrons to form Cr3 plus 1 electron, right? And this is my oxidation equation. And I'm now, although it's right in front of me, but I'm just, let's ignore that. Okay, let's just ignore that. And they're looking for the reduction equation. They've given us the final. So they're asking, what is the reduction equation? So I know that this equation adds up with some other equation to give me this. So I'll just simplify things and I'll start finding things. So for example, so first thing I'll notice is I got Cr2 plus over here, there's 6 Cr2 plus. So that means the only way I can have 6 Cr2 plus in the final equation is that this multiplies by 6. Then what do I see? Anything that's missing over here in the final equation would probably belong to this other equation, which is Cr207 2 minus is missing. Because remember, these two equations are going to add up to give me this. 14H plus 1 is also missing. So that kind of sums it up. And just 1 second, I'm not sure why. Here. Right. So what else? 6 Cr3 plus must add up to something. So there's 2 Cr3 plus missing. Like I need 8 Cr3 plus over here. So there must be 2 Cr3 plus on this side. And there's 7H2. So there must be 7H2 in this other equation. And there's 6 electrons over here, and there are no 6 electrons showing up over here. So there must be minus 6 electrons. So that is my missing equation. The only thing I need to do is I need to bring the minus 6 electrons from this side. And if I take them to the other side, they would become plus 6 electrons. So I get exactly the equation that we used to make this equation. So remember how to do this. So I'm going to quickly move to the next question now, which is that ignore this. They're just asking you to draw a fully labeled diagram of the apparatus that could be used to measure the standard E0 of the O2 in half cell 1 under standard conditions. So I think they are specifically talking about this reaction, the water, oxygen, and H+1 reaction. So you need to make an electrode. Now it involves oxygen gas, so that means, and you can even, if the data booklet is given to you, you can even have a look at this reaction. This is the reaction where O2 and 4H+1. So if you have a look over here, you'll kind of spot this reaction somewhere. It's probably this one. This reaction over here. They're actually talking about this electrode. Now this electrode over here involves oxygen gas, and it involves an acid as well, H+1. So oxygen gas, whenever you have a gas, it's a gas electrode. So I'll just I make a gas electrode over here. Let's do it over here. So it involves oxygen gas, so there must be a gas jar, and there would be oxygen gas at a pressure of 1 atmosphere. And there's going to be a solution, and that solution is going to have H+1 ions, aqueous, and their concentration is going to be 1 mole per decimeter cube. So it's probably HCl or some other acid. And what would the electrode be made up of? Any idea?
Say H+1 ions की होंगी. I mean,
This is the reaction we're talking about now. He's saying construct an electrode for this reaction, this one. So the reaction has H+1 ions.
oh, ठीक है.
Okay. You're not going to write water, because when you write aqueous, that means water is pretty obvious. There's going to be water, so you don't have to obviously write water. Achha, what is the electrode made up of in this case? Like whenever you have a gas electrode, it's going to be made up of platinum. Remember, there are 3 types of electrodes. So it's going to be made up of the platinum electrode. And he's saying a fully labeled diagram. So tell me what's missing now. Does anyone know what's missing now?
The temperature and the atmospheric pressure.
No, I've given the atmospheric pressure. I can add the
The
temperature.
salt bench.
But the whole thing, like what do you measure it against?
Oh, hydrogen
The sheet-
electrode.
You measure it against a standard hydrogen electrode. Okay, he didn't tell us, but he said you have to measure the whole electrode potential. So it's going to be measured against the standard hydrogen electrode. You're going to draw that, and it's going to be a gas jar as well. It is going to be H2 gas, and you're going to label it. It's a 4-mark question, so it's going to be 1 atmosphere pressure, and there's going to be platinum, a platinum electrode as well, and the solution will have H+1 ions, and the H+1 aqueous ions will have a concentration of 1 mole per decimeter cube. And then you're going to connect the 2 electrodes together. So there's going to be voltmeter and there's going to be a salt bridge as well. And you're going to label the salt bridge 2. So remember, these diagrams are very important. Usually you get I mean, the question usually starts with a diagram. Now he's saying for the cell drawn, use a data booklet to calculate the E0 cell and deduce which electrode is the positive electrode. Now we know this one is the zero potential. This is the reference electrode. So this one is 0.0 volts. We already know that. What is this one? This is given in the data booklet. This is the one that we found out just right now. It's this electrode with oxygen and H+1 in water. That's 1.23 volts. So this one over here is 1.23 volts. So tell me which one out of the two is the positive one and which one is the negative one? Like which one is the positive electrode? Or in what direction would the electrons flow? Anyone, any ideas? Or remember this high E0 is the Ibrahim pata tha?
जी से पता.
So high E0 is the positive one, right? It's this one. It's the higher potential. Remember, the potential values are completely irrelevant. It's always a relative comparison. So the electrons are going to flow from left to right, from the negative side to the positive. And negative positive is not the. I mean, the lower potential is the negative one, and the higher potential is the positive one. Anyways, they didn't ask for the electron flow. The E0 cell is going to be 1.23 because the other one is 0. So the potential difference is going to be exactly 1.23 volts. And the right-hand electrode. Now the next one is, again, this one. By looking, no, is it this one? They're saying use data booklet to predict whether the reaction is feasible when aqueous solutions of iodate 5 ions and bromide ions are mixed. Now, iodate 5, I don't think the data booklet has any equation involving iodate 5. I mean, if you have a look, there is no equation on IO3. I don't think so. Like, I mean, there's only one equation for I somewhere, which is this one. But nothing to do with iodate. So yes, yes. So I mean, it's the standard. If you use the word standard, it's always going to have 0 volts. And the reason is because you're not measuring its potential. You just say, okay, it's. I gave you an example. Let's say you're measuring the heights of the building. So you need a reference point, right? So you take sea level and you say that sea level has 0 height, right? So the thing that you're measuring it, everything else with, it's always going to have 0. That's going to be your 0. Zoe, is this clear?
Yes, sir.
But non-standard, I told you that the potential could increase and it could also decrease. It could become higher or lower if the equilibrium shifts when you change conditions. Now, bromide ions, the reaction he's asking for is with bromide ions. So have a look and somewhere in B, there's bromide ion, and that there's only one equation, which is 1.07 volts. So I'll just write that. So it's Br2 plus 2 electrons in equilibrium with 2 Br minus 1.07 volts. So that's my higher potential. This is my lower potential. So that one gains electrons. This one loses electrons. The electrons need to be equal. So I need to multiply this by 5. So this becomes 10. And this also becomes 10. And the top one needs to be multiplied by 2. So this becomes 12. This becomes 10. This becomes 1. This becomes 6. So I need to make the electrons equal. So I've multiplied both equations by a certain number, and I'm going to add up the reactants and products. The reactants in the first one is 2IO3 minus 1 plus 12H plus 1. And in the bottom one, the reactant is 10Br minus 1. And the products are going to be in the first one, it's going to be I2 plus 6H2O. And in the second one, it's 5Br2. So iodate 5 and bromide are reacting. I mean, you need an acid for that, but he did use an acid, it was acidified. So these two are reacting. So he's saying use the data booklet to predict whether the reaction is feasible. It is feasible because it is happening and they have an E0 cell as well, which is positive. Reduction potential minus oxidation potential, 1.19 minus 1.07. And I get something that is 0.12, which is positive. So you're going to write that the E0 cell is coming out to be greater than 0 volts. So hence this reaction is, it's not going to be very fast because the potentials are very close to each other, but theoretically speaking, it is possible. Okay, is this clear, this question?
Yes, sir.
sir.
So now this one we have he's saying aluminum is extracted by electrolysis. And the half equation for the reaction at anode is shown. So this is what's happening at anode. Use this equation to write the ionic equation for the electrolysis of Al2O3. So I mean, we know at cathode it's aluminum that's getting formed. Aluminum ions go and they gain electrons and they form aluminum. So that's your cathode equation. So all you got to do is add up the two reactions. Again, make the number of electrons gained and lost equal. So 2. So I'm going to multiply the first one by 3. So it's going to be 3 carbons, 3 carbon monoxides, and this would be 6 electrons. And this one I'm going to multiply it by 2 so that this becomes 6 and 2. And you add up both. So 3O minus 2 plus 2Al plus 3 plus 3 C's as well. And the product is going to be 3CO plus 2Al, I think. ठीक है, hopefully
Shit, तो हमारे पास तो overall equation है ही तो.
we were supposed to make the overall equation, like the ionic equation.
अच्छा, लेकिन फिर we didn't have the other half equation. I mean,
That is, I mean, this one was a guess. I mean, it wasn't just a guess because they told us that you're extracting aluminium from aluminium oxide, right? So basically aluminium plus 3 would be changing into aluminium, right?
जी.
Like, let me I mean, that's the only possibility. Like, I mean, this I mean, you have studied this in O levels as well, but you know that aluminium is getting reduced at cathode because you are extracting aluminium. So aluminium ions in aluminium oxide would be turning into aluminium. So that's kind of obvious. Now the next one is about the Faraday constant. Aluminium oxide is extracted for 3 hours using carbon electrodes and a current. First thing, time and current is given, so you can find the charge. So Q is equal to IT. What is 3 hours? 3 hours into 3600 seconds. That's the time, and the current is 3.5 times 10 power 5 amperes. So can anyone quickly tell me what do we get for this? Does anyone have a calculator here? Dina, you did Hafsa?
3.78 times 10 power 9.
So you're getting 3.78 into 10 power 9, right?
Yeah. Yeah.
So that is the coulombs that you get, right? Now, when we're doing this thing, I told you that there's a Faraday constant, which is Okay, Faraday constant tells me that 1 mole of electrons has a charge of 96,500 coulombs. So you have had these many coulombs. So how many moles of electrons do you have? So it's going to be 3.78 into 10⁹ divided by 96,500. So what do we get for that?
$39,171.
31,171.
39,171.
Moles. Of these other moles. So you're getting moles of electrons, right? So that's, I mean,
Yeah.
that's kind of a lot of electrons. You kind of had a very huge amount of current for a very long time. So that's like a lot of moles of electrons. Now, all you have to do is you found the moles of electrons, so you have to find the mass of aluminium. So you have the ratio 6 electrons produce 2 aluminiums. So it's 1/3, like 3:1. So see, if you have these many moles of electrons, the moles of aluminium would be divided by 3. What do you get?
13,057.
30, 13
13,057.
and 57 moles of aluminium, and you have to find the mass, so it's going to be multiplied by mr, which in this case is 27.
So इसके बाद what did you do ये 39,000
वो
को
था ना
क्या
कि
करके
electrons and एक second, electrons and aluminium have a ratio of what? 3:1, right? Like
हाँ
6.
जी ठीक है
So if you have
ठीक
the
है
moles of electrons, the moles of aluminium would be 1/3. I mean, what we did was we divided it by 3. Okay, so is this clear? So now the next one is just I mean, forget that, you just have to write an equation. Let's do this one. So you're given, define the term standard electrode potential. So the definition, it's given in the notes. I'll try and send the notes after this class, and the worksheet as well. So the definition is that it's a potential difference. Potential difference measured between a standard electrode and a standard hydrogen electrode. And measured under standard conditions. So you're supposed to do that under standard conditions. And he's asking you to draw again a 4-mark question on drawing a diagram. So draw a fully labeled diagram of the apparatus that would be used to measure the standard cell potential. So they're two different things, and you have to draw the cell potential. There's one electrode, which is the gold. Whenever you have a metal, the metal itself is going to be the electrode. So that's Au. And gold ions. Gold ions are going to be part of the solution, which is going to be, so it's going to be Au3 plus. And the Au3 plus aqueous solution would have a concentration of 1 mole per dm cube. The other one is a gas. It involves a gas. So if it involves a gas, it's got to be a gas jar. So there is NO gas, which is coming in, and that NO gas, and there's going to be nitric acid. And that nitric acid, which is aqueous, should have a concentration of 1 mole per decimeter cube. And there's going to be, whenever you have a gas electrode, there's going to be a platinum electrode. And you're going to connect the two together and you're going to measure the voltage between the two. And there's going to be a salt bridge. And you'll label the salt bridge as well. So that's how you're going to get the 4 marks. So just remember that how you're going to, if there's a gas, there's going to be a gas jar and there's going to be a platinum electrode. If there's a metal, the electrode itself would be made out of a metal. So moving on, they're asking, write an ionic equation to show the spontaneous reaction that occurs when electric current is drawn from the cell. So I'm assuming it's this one. It's the gold. So I've got gold with gold ions, Au3+. So that's one of the electrodes. The Au3+ and Au electrode is that one, and the one involving NO gas, that's the other one. So I'm assuming it's these two, because I mean reaction number 2 is probably has nothing to do with this. It's gold and gold ions and NO and nitric acid, HNO3. So the first one is the higher potential, it gains electrons. The next one is the lower potential, it loses electrons. And the electrons are already balanced, so it's going to be Au3+. So it's got to be Au3+, and at the bottom it's NO. And there is 2 H2Os. And the products in the first one is Au, which is solid. And in the second one, it's NO3 - 1. And 4H+1. And the electrons are already balanced. So that's it. And he's asking to calculate the E0 cell for this reaction. So it's a higher potential or reduction potential minus the oxidation potential. So it's 1.50 minus 0.96, and you're going to get 0.54 volts over here. So is this clear? This one?
Yes,
Okay.
sir.
Yes, sir.
So let's continue with this in the next class. I'll send you the notes and the worksheet both. Try and do some of these questions, and we'll complete this worksheet. We'll try and complete this worksheet in the next class then. So okay, everyone.
Thank you, sir. Allah Hafiz.
Thank you.
Take care, Allah Hafiz.